welcome everybody. Looks like we've got a nice group this afternoon for the webinar. And I presume that everyone has, just about everybody has turned off their microphone through Illuminati and now is on this audio. So I'm going to go ahead and begin and welcome you all to today's live web event, Advancing Environmental Literacy About Transitions and Tipping Points in Complex Environmental Systems. I'm Susan Usante. I'm the program at the American Institute of Biology. And Diane, I work to give you a overview of the Illuminati interface.
Hello, everyone. This is Diane. A quick introduction on Illuminati. If you haven't already, or in the audio section of the Illuminati box, you're going to see a little microphone on the bottom. So you'll go ahead and click on that. If you have not already done so, a pop-up box will pop up and giving you instructions on how to call in. And just go ahead and click OK. And you will see next to your name, under your participant's name, you'll see in this area right over here, you'll see it change over to a phone receiver. You have a couple options with the Illuminati platform. We have the option to raise your hand, which you will see underneath the participants box. If you have any questions at any point in time, please feel free to raise your hand or feel free to chat in the chat box, and we will try to get the presenters to go ahead and answer those questions for you. We also have another option that we will be using, and that is going to be in the actual whiteboard section. You'll see there is a little pen wand looking little button. If you click on that, you'll see in the bottom of the screen down, I believe it's like right around here, down below. I can't put my red circle that low. There will be a box pop up with different icons that you can click on, and that is something that we're actually going to use in a moment, where you can pick one, and I believe Susan is going to show you what to do with that now. If you want to go ahead and place on the map so you can get a little familiarized with the Illuminati platform where you currently are at. So for instance, if you're in California or North Carolina, Washington, go ahead and pick an icon and drop it down.
There we go, great.
And you can move it around a little bit too.
It's a little tricky to sometimes place little dots, but it looks like we've got a lot of East Coasters, people in the middle of the country. Right. Okay. Excellent. Well, thanks, Diane, for showing everybody how to use the Illuminati interface, and feel free as we're going through to raise your hand or let us know if you're having any questions. Diane, I'm going to continue, and I see Susan has her hand raised. You can get with her. That would be great.
Yes.
Okay, super. Thank you. All right. Well, let me give you a quick introduction. In the spring, the Ecological Society of America contacted AIBS to ask us how we could help support their Ecology and Education Summit that's taking place just next month. And we learned that their plans were to bring together a diverse audience to create a national dialogue to accelerate the transformation of teaching and learning at all types of educational settings in response to today's urgent and complex environmental challenges. You can help inform the process that they're going through right now by taking the survey, which is available through the Summit website. So it occurred to us at AIBS, as we learn more about the plans for the Summit, that we could maybe help facilitate a connection between the goals of the Summit and the information and recommendations in the latest version of the Transition and Tipping Points in Complex Environmental Systems, published by NSF. Dr. Joseph Travis is both the current AIBS president and a member of that committee that wrote this report. So he invited a group from the committee to present an overview and some examples of what's happening today to move the recommendations forward. So I'm really pleased to be able to present to you today's speakers. Our first speaker is Dr. Susan Stafford. And she's a professor of environmental science, policy, and management, and Dean Emeritus in the Department of Forest Resources at the University of Minnesota. And after nearly a decade of higher education administration at 3 land-grant universities, Dr. Stafford is now focusing her research interests in 2 major areas of emphasis: facilitating and understanding interdisciplinary research and education, and using visual analytics to aid in the flow and understanding of environmental data and information among researchers, practitioners, and stakeholders. Dr. John Moore will be giving the second part of today's presentation. He's the director of the Natural Resources Ecology Laboratory at Colorado State University. He studies food web ecology using soils as a model ecosystem. And his current studies include tropical rainforests, grassland, dry caves, and the Arctic. His work in education centers on research in teaching and learning and professional development for K-12 students and teachers. And our third speaker is Dr. Alan Kay, who's the president of Viewpoints Research Institute in California, a nonprofit incorporated just 9 years ago to improve powerful ideas in education for the world's children and to advance the state of systems research and personal computing. And Dr. Kay is a computer scientist who, at Viewpoints Research, continues his work with powerful ideas in education for the world's children, the development of advanced personal computers, programming, and network systems. And finally, Meg Lowman will be the moderator for the second portion of the afternoon. She's also known as Canopy Meg, and she'll be connecting today's presentation to the summit and moderating the question and answer portion. She's really a pioneer in the science of canopy ecology and inspires sustainability efforts throughout global forests. So, now that I've introduced you to the speakers, we're going to go ahead and get started with Dr. Stafford.
Hello, everybody. Can you hear me?
You can clap your hands if you can hear it.
Okay, terrific. Well, welcome, and thank you for taking time out of your busy lives to spend some time and talk about something that's near and dear to everybody here. The report that has been mentioned is a product of the Advisory Committee of NSF on Environmental Research and Education. And the report is available at this website for those of you who would like to read it. The ACERE, as we are called, is a unique committee within NSF because instead of an advisory committee just reporting to a single directorate, because the environment and all of the science and engineering that is part of it is intrinsically multidisciplinary, it has to involve all the parts of NSF, and as such, we reported directly to the director and the deputy director. And we took our mission very seriously. We created in 2009 the culmination of our work that is represented in transitions and tipping points in complex environmental systems. We called our report the Green Report, if for no other reason. The first one in 2003 was red, the second one in 2005 was blue, and because we saw our mission as really a call to action, we thought green represented our emphasis very well. Now, there are 3 different foci of the report, but what we are really here today to talk about is the part on environmental literacy. We had 5 different recommendations, and I recommend that you look at the report to get a better understanding of all of them. But really, what the emphasis that we wanted to focus on was the sense that we had that we really needed to improve environmental education and increase the public's engagement in environmental science. When we say environmental science literacy, we are meaning the capacity to understand and participate in evidence-based decision-making about socio-ecological systems. You only need to go to the popular media and literature to see how important this is becoming. We focused on all levels of environmental literacy, citizen scientists, K through 20, and both formal and informal venues. John Moore, who will follow me, will basically focus on the K through 20, and Dr. Alan Kay will focus some on different mechanisms and different ways, unique ways of showing instructional models that can be very useful in engaging students in ways that perhaps we had not been able to in the past. I'm sure many of you at your home institutions have good examples. Here's one that I would be remiss if I didn't include, Dr. Karen Oberhauser and Monarchs in the Classroom. We also, within our conversations of the committee, realized that we have this unique opportunity to take the world that is occurring around us in other areas and find those teachable moments to explain tipping points. The collapse of the global financial markets, biofuels, which ESA has just focused on, are two good examples. The reason that we felt that environmental literacy was important is that we put this in the larger context, and that was that we want a populace that can understand what policymakers are wrestling with and also provide insight to the policymakers and vice versa. As the kinds of models that we are seeing are integrating data into end-use systems, we can see how an environmentally literate society is going to be in everybody's best interest. So we view ourselves as recommending and strongly encouraging ways to engage the citizen scientist in environmental research. And what we have done here today is to lay out for you some of the strategies that we are aware of. And now I will turn it over to Dr. John Moore.
Thank you, Susan. What I'd like to do is elaborate on one of the recommendations that we made in the report, and that was to utilize the different networks, research networks, monitoring, research, and otherwise that we have across the globe in the country. I'm going to highlight work that we're doing through the long-term Ecological Research Network that's funded by the National Science Foundation. The map on the left-hand side represents the location of the 26 sites within the network. And the demographic data on the right-hand side is the result of a survey that we did back in 2007 that focused on the schools and districts that we're working with, the number of students that we could potentially impact given the schools and districts, and then a bit about the socioeconomic status, ethnicity, and the disaggregated ethnicity of those students. So what I'm going to do is present a case study of how we've utilized this network for research in the area of teaching and learning with our students, but then also as a platform for professional development from teachers in a way that was informed by the research. The project that I'll be talking about is our Mathematics and Science partnership funded by the National Science Foundation. The title or the name we've given ourselves is Pathways to Environmental Literacy. I've listed the partner institutions on the right, and I've circled the LTER sites and the network office, the LNO office in New Mexico. These are our partner LTER sites. I'm the principal investigator at Colorado State University. Alan Berkowitz, who many of you know at the Carey Institute of Environmental or Ecosystem Studies, is also a co-PI. Allison Whitmer at Santa Barbara. Andy Anderson at Michigan State University, Sarah Haynes at Towson, Bob Wade at New Mexico, Bill Hoyt at the University of Northern Colorado, Bob Mays at the University of Wyoming, Beth Kovich at Montana State, and Kristen Gunkel at Arizona State. And there's many other people involved, many graduate students and postdocs, and what I'll try to do is give credit when credit is due. So, two aspects we'll look at. First, we're going to look at an example of how we could use the network as a research platform. Clicking the wrong button there, sorry. Okay, the research that we've conducted is looking at the concept of learning progressions. And I've listed a variety of topics, 3 science topics, quantitative reasoning for mathematics, and the connection then to our population through citizenship, culture, and place. These topics emerged from discussions that LTER scientists had at a meeting about 6 years ago, where grand challenges were identified and directions that the network might want to take to address those challenges were identified. And in those, biogeochemical cycling, biodiversity were among the top ecological or content areas. And then the socio-ecological perspective of the relationship between humans, decision-making, and their actions on the environment was also paramount. And from that, the topics that we have bulleted here emerged for us to study in relation to environmental literacy. So what is a learning progression? Well, a learning progression really is a description or a series of descriptions of increasingly sophisticated ways of thinking about a subject. And it involves aspects of the content knowledge the student possesses, their practice, and the discourse, the way in which they discuss the items. At the lower end of a learning progression, basically we're looking at how younger students reason about a concept. The upper anchor, or end of the learning progression, is defined by what experts in the field believe students should understand when they graduate. And then we have the various levels in between. So in creating a learning progression, essentially the framework needs to be identified, and this usually centers on identifying key principles. So for example, in the area of biodiversity, principles might include natural selection, genetic variation, multiple generations, things of that nature. So the framework is constructed, and then written assessments are created focusing on various progress variables: selection, diversity, stability, interactions, depending on what aspect of biodiversity we're looking at. We then administered the assessments across 5 states. We had about 1,000 students involved in the survey. And then we create rubrics for scoring each items and then characterizing them based on a variety of different response variables. We had 40 different questions that the students were asked. And then we coded all the respondents. And then looked for qualitative and quantitative trends in the way in which students answered the questions. So what I'd like to do is give you an example of a question and how it played out. So here's a sample question on selection. A farmer often sprays their fields to help prevent insects from eating their crops. Over time, the insect population slowly becomes resistant to these sprays, and so the farmers have to use different sprays to protect the crops. Describe how the insects become resistant to the sprays. So this work was led by Dr. Laurel Hartley. She's at University of Colorado in Denver, and a group of us across our network. So let's take a look at how different levels in the learning progression play out. At the lowest level, we tend to see what we call forced dynamic narratives. Basically, the students take an anthropocentric view of the world, and things then are responding as actors on a stage. So in this case here, for example, a student might say that the bugs build up a strong immune system in order to withstand the sprays. If they don't have a strong immune system, they die. It tends to be focused on the individual. The second level involves that forced dynamic narrative, but often will include a hidden mechanism. So in this case, the student might respond, after a while the bugs keep getting killed, so through natural selection the bugs change and become resistant to the spray, so they're able to survive. Note here that there's a mechanism involved, but again the student is looking at a single generation and the bug as an actor. At the third level, we begin to see a little bit more sophistication, but we see what we call our school science narratives. So the topics that are discussed in school are strung together. We see mechanisms at play, and in this particular case it's the wrong mechanism, but nonetheless it's there. So the increase in resistance happens when parents have taken it for a while and then have offspring. Then the offspring will have more resistance to it. At least this student is seeing multiple generations, but obviously an incorrect Lamarckian mechanism is involved. At the fourth level, we have what we call qualitative model-based accounts. So the school narratives are in place, but mechanisms are attributed in an appropriate manner. So for this example, during the first spraying, a couple of insects who were resistant, probably due to a genetic mutation, survived and reproduced, creating more resistant offspring until eventually the chemicals were basically ineffective. So the student then has taken the basic principles, applied them in an appropriate manner, and provided mechanisms. Here you have multiple generations at play. So to summarize, if we were to look at the kinds of responses that we get when asking questions of this sort, the first level essentially has comments like get used to, adapt to, become immune. They may mention selective pressure, but again, the animal in this case was an actor. The second would provide a hidden mechanism, but usually just focusing on one generation. The third might be aware of multiple generations, but gives an appropriate mechanism, in this case a Lamarckian explanation. And then the fourth would recognize that there's genetic diversity, differential survival and reproduction, and evolution as a multi-generational process. So what we see then are, again, the principles being applied in an appropriate manner. So what happens if we look at middle school and high school students across the network in the way in which they responded? Here we have the percentage of students that respond to each of the different levels within the learning progression. The dark green students are in middle school. The lighter green students are in high school. And I think what you see here are a couple of trends. First off, the vast majority of students are using the force dynamic reasoning or lower level responses. And then we see fewer students showing increased understanding or movement up the learning progression. We also see that high school students tend to show better performance than middle school students. So I think that's an encouraging sign. So if we were to summarize the findings from the biodiversity as a whole, first thing is we've learned, and this includes not just this example but other questions, that students don't really recognize biodiversity and don't have the necessary observations needed to make sense of the principles. So for example, they're not seeing phenotypic changes in populations, and so forth. Many students have an anthropocentric view of organisms and their role in the environment. Death is not recognized as commonplace. Students often see survivorship curves akin to what humans have. They don't understand that there are different life history strategies. And when plants are in the mix, the life cycles of plants are sufficiently different from those of animals, and yet students don't know the difference and seem to apply human-based life history strategies or life cycles to all animals. Let me give you a second example. This one was conducted by Kristen Gunkel at Arizona State University and her colleagues. And it was looking at an aspect of water, in this case a cluster of aquifers. So the idea here was students were to interpret the diagram, and then the questions were asked in relation to the different wells and the sources of the water. I'm going to just jump right to the results. I'm presenting them in a slightly different way. Level 1 is in blue, 2 is in red, the green is level 3 in the progression, the purple is level 4, and we're looking at high school students and then their teachers. And what we find here is that teachers tend to do a bit better than their students in the learning progression. Most of them, though, are showing the level 3 type responses, which are the classroom-based accounts, if you will, of the different principles. I think what's striking, though, is what you find here is that not many more teachers are performing at level 4 than their students. And this was a trend that we saw on several of these types of comparisons. The school-based narratives seem to be trumping, if you will, really a deep understanding of the different principles. So what were some conclusions and implications from this work? Well, obviously not as many teachers performed as level 4 that we would like. The school science narratives predominated in the schools. And really, if we're going to support students in achieving the model-based learning, changes in instructional strategies are probably at play here. We're definitely going to have to look at different ways of approaching science reasoning, and particularly in socio-ecological systems in general, in this case water. So what did this work tell us? Well, it really informed us on how we might use the network in our professional development, and really stressed the need, in our view, for an apprenticeship-based model that immerses teachers in the practice of science. Now, many of you are familiar with the National Science Foundation's initiatives in this area. There's the Research Experience for Teachers, there are Teachers in Residence programs, the GK-12 program, and then the LTER network is supporting what's called long-term schoolyard ecology. One thing, though, that we recognized is that in the survey that we had conducted earlier is that how different sites practiced these different programs varied tremendously. And so the immersion model that we've proposed is one that uses the network that does involve teachers on projects, the teacher in resident program, graduate student or K-12 program, integration into the classroom, but focuses all of this towards the aim of environmental literacy. And so that teachers from one site can visit another, and there'll be a seamless transition, if you will, in terms of the content, the experience, and its application to those basic principles. So with that, I'm going to turn it over to Alan Kay.
Thanks, John. Thanks very much. So Alan, we are ready. Are you ready to unmute your line and show the simulation? You'll have to hit *6* to unmute yourself. And Susan and John, if you wish to remute yourself, you'll have to hit *6*. And it should tell you that. There we go. Okay. So in front of you, we can't hear you yet, Alan. But in front of everyone, you should be seeing an application sharing window popping up.
Okay, hello.
Hi, Alan. Yes, we can hear you now. Great.
Okay, great.
And just so you know, you do have the ability, participants have the ability to scroll side to side. So you may need to use the bars on the right-hand side or the lower.
When I tried this yesterday, after one shot, it readjusted to the screen. But in this case, it doesn't matter.
Okay, great.
So this talk is actually ecologically complementary to Susan's and John's, as you might expect, since we're all in the same committee and have very similar feelings. And my little talk is about models. My background before I got seduced by computers was I have degrees in mathematics and molecular biology. I got into computing because this idea that I had in 1968, which is called the Dynabook, was when we realized it would be possible in a decade or so that every child could have a portable laptop computer wirelessly computing and communicating. And a bunch of us were actually also working on the ARPANET, which became the Internet at the time. And so this is kind of the modern manifestation of it, along with many netbooks and, of course, the iPads, this is starting to happen now. This is the OLPC EXO, and there are about 3 million in the world today, most of them in third world countries, and the software I'm doing this presentation in runs on that machine and about 100 other ones. And so one of the big motivations for inventing personal computing was that they could be dynamic media. So the irony is that almost all use of personal computers today is to show simulations of old media, like old acetate slides are now in PowerPoint and so forth. But I'm not going to do that today. This is actually not PowerPoint I'm using. I'm going to use the system the children use and show you what occurred to me while we were working on this book. There it goes. So I came late to this book. It was getting on the way towards being done, and I was really excited about it. But my sense was, hey, we're talking about dynamic systems, and especially dynamic systems that can topple. And we're trying to explain all of this in a book that doesn't have any dynamics in it. And moreover, most readers of this book, including the politicians who are reading it, probably don't have a great idea about what actually happens down on in ecologies and down towards the molecular levels where a lot of the cause and effect relationships actually happen. And so my desire was to open a hole in this book and be able to do something dynamic, like here's a little system pointing out, and I wanted to be able to let people hit this system with the hammer and let the systems are actually dynamically stable, not statically stable, and if you hit it a lot, it doesn't come back. And the simple model here is just something like a globe sitting on a pedestal, and we can think of that globe as the Earth, and we're hitting it, and it's recovering, but if we hit various aspects of it hard enough, it'll just topple. And this is a graphic illustration to a person of any age that once something like that is toppled, it's going to take more than a simple hammer blow to right it again. And that is one of the main points they would like people to understand viscerally about complex systems, is that the reversibility of these systems may be orders of magnitude beyond our resources that we use to topple it in the first place. So we have to be careful when we're playing around with them. And the way we deal with these ideas with children is to actually get them to build from scratch models of things. We don't try to give them catechisms to memorize because they require belief, and what we want them to do is to have some sense of how cause and effect mechanisms work. And so here's an example. I'm doing a little painting here, and children like to make little robot cars that they can learn how to drive. I'll put some wheels on it. I'll put a couple of headlights on it so you can get a sense. This is a very typical project done early by a 5th grader, okay? And it's a graphic object, and I'll call it a car. But I can also look inside this car, and I can find some properties of the car, and I can make a little script like car turned by 5, and I've got that script ticking. And if I wanted to go forward, I can pull out a tile here and drop it in, and now the car is going forward and turning at the same time, so it's making a circle. And in fact, I can duplicate, I can catch it. I can duplicate, I can make as many cars as I want. And I'm going to repaint one of these cars. Notice I'm doing all of this while it's going. And I'll paint this one blue. Now I've got a blue car and a red car, and I can do things with these. So here's one use of a blue car and a red car, is to show why life can actually even work at all. And this is because the amount of movement that is going on at the molecular level inside of a bacterium is completely beyond our understanding. For instance, a protein molecule in there, the bacterium has about 120 million of them, is actually rotating at about 1 million revolutions per second. And it's traveling its own length every 2 nanoseconds. And so it looks like an incredibly crowded environment inside this, and it seems impossible that any protein molecule could find another protein molecule to make something happen. In fact, if we start them rotating here and then start them going, they're just randomly moving around, being buffeted. And this is incredibly slowed down compared to real time. And now they've found each other and they've docked and they've become something new. And in a regular bacterium, that happens on the average. Each protein molecule touches every other protein molecule about 2 times a second. So there's an enormous amount of activity in there, and this is why life can happen at all. Another use of these 2 cars is to think about disease. Remember, all of these programs here that I'm showing you are ones that the children do themselves. We do not give them pre-done programs because we don't want there to be any mystery about this. This is the basic difference between science and religion, is we want to remove as much mystery as possible and have some sense of what's actually going on. And so now I'm going to make these cars really small and have them play the part of villagers, and the red one is infected and the blue one isn't infected. And you can see the graph at the top of the screen there. They're not touching each other, so the percentage of infected and non-infected is staying about the same. Well, I can get as many cars as I want. Let's try 1,000 here. So now I have 1,000 non-infected and 1 still infected one, and I'll set them going. And you see lots of things happen in a hurry. We get the traditional S-shaped curve here. And everybody winds up dying. And now the kids will try a much smaller number, like 100. Notice it's sparser, and this means the probability of infection is going to be lower. So what is usually a time constant in an equation looked at by a high schooler or a college student is actually done spatially here. So if I tell all these guys to go, it's going to take longer. But in fact, you get the same rise, and eventually all of them will die. This first curve is like typhoid, and the second one is like AIDS. And AIDS is deadly because when we don't see much of anything happening, our nervous system concludes nothing is happening. Whereas in fact, both of them are part of the exact same kind of exponential progression, which is going to be deadly in each case. And in many ways, the AIDS one is more deadly because you have to be sophisticated to understand that it is deadly. Here's another example. These are gas particles. I'm skipping a lot of stuff here. So in between, we learned 10 reasons why there might be atoms. And now we've got 1,000 of them. This green bar here is being floated by the pressure momentum exchange of these 1,000 atoms. So if I put 500 in here, we'll get half as many bumping the green guy, and it's pulled down by gravity to about where we'd expect it to go. And I don't know whether this will work in the screen sharing, but if we put 2,000 in there, we get something that's both expected and unexpected. We get an explosion, we get shock waves, and a whole bunch of emergent behavior here, and a return to equilibrium that's about twice as high as it was before because we have twice as many little guys bumping it on average.
Yeah, I'm not seeing the explosion part down, so.
Well, that's the problem with Illuminate, isn't it?
Yes, yes. You'll need to fix that.
Okay, so again, we can also look at other uses here. So here's an example of buoyancy. I think the system works as long as there's not a lot going on. So if I take the gravity, make it lower here, we still get buoyancy. You can see it a little bit better. And if I
it might actually right now be trying to catch up with you, and that's what I'm thinking it might be happening, because it's now moving very slowly. We're not seeing very much.
Yeah, well, yeah, my cursor is frozen.
Okay.
So I'm not getting, maybe I can go back to the other. No, that's too bad. So, however, I was almost done, and I'll tell you what the next one was to try the predator-prey models, first with foxes and rabbits, and then to think about pine bark beetles and pine trees, which is currently devastating Alaska just because the average temperature has gone up a few degrees. And so forth. And the idea here is by using exactly the progression that John was talking about, of trying to get away from story-based and school-based explanations to try to get to real model-based explanations, and model-based explanations that are actually operationally part of the child's way of thinking, allows them to not be passive acquirers of the idea of models, but actually to make all of these models and to get a much stronger idea of how systems can apparently be stable for a long time, but because there are variations and we can inject various causalities of our own into it, and we can topple that system. And when you topple a species, it doesn't come back. So very often in the rabbits and the foxes one, after you've let it run for a couple of minutes, the foxes will eat all the rabbits too quickly, and there won't be any more food left for them until the rabbits are gone, and then the foxes go, and both species have died. So that's my presentation of just pointing out that if we really want children and adults to understand about these complex nonlinear systems, it's perfectly easy to do it, but we have to do it by having them actually build their own versions of systems in a way that is viscerally meaningful to them. Thank you.
Thank you, Alan. That was neat. Hopefully most everybody saw the beginning part where it wasn't working very well. So Diane or Alan, if you could remove the application sharing window, that would be great. And then we'll have Meg. Meg, are you there? You'll have to hit *6* to unmute your line.
Okay, thank you. Can you hear me?
Yes, can hear you now. Great. Welcome, Meg.
Fantastic. This is also exciting. And I guess the screen will advance for me as well.
I can do that. Yep.
Yeah, you are too wonderful. I know I can take the button myself from now on. I want to thank everyone, first of all. This is Meg Lowman. I am the Vice President of the Ecological Society with the portfolio of education and diversity. And just by way of a little understanding of how we got where we are, this has been in the making by ESA for some 5 years and was basically catalyzed in our ecological community by recognizing that so many of us oftentimes came together at the annual meetings from California and Florida and New York, for example, and found that we were working on similar things. And we lamented the waste of time, energy, and funds because there isn't really some kind of Amazon.com for comparing environmental education tools as much as we would wish. And in sort of planning this, we came to find out this August that Congress had mandated another summit that was by White House decree to occur before October 1st. And so summit number 1 became the Sustainability Education Summit, that was funded by the congressional decree that we in turn needed to scramble a little and make sure that our summit dovetailed and followed on from that summit number 1. So I wanted to just give you a couple bullet points from that summit, since NSF and other bodies are obviously looking for us to walk the talk. We don't want to be redundant with what's already been discussed, and we want to move everything forward. A huge thanks to Teresa Murad at ESA and Carolyn Breedlove at NEA and all of you guys on this webinar, because everybody has contributed so much time and energy. But last week's summit basically was entitled Sustainability Education Summit, Citizenship and Pathways for a Green Economy. And the take on this was that it had an economic base. The big umbrella is ecological or environmental literacy, but this summit number 1 did have a real economic theme. In contrast, our summit in October will have a much more ecological or education-based theme, but nonetheless they really do go hand in hand. According to a lot of the government folks that were in Washington for summit number 1 last week, it was the first time that many of them were together in one room, which represents a milestone for the White House, I gather. Things that all of us might take for granted are sometimes a little harder to come by in governmental worlds. And secondly, there was an action list created the very last hour of the day-and-a-half meeting that will be shared, we hope, in draft form by the time our summit comes to pass on October 15th. Everyone at this summit number 1 agreed that sustainability should be an organizing principle. They even went as far as to say maybe we need STEM instead of STEM to insert that H for humanity and issues that are in addition to science, technology, engineering, and math. So it was quite a lively dialogue along those lines. Some of the real take-home lessons came from some of the keynote speakers. Michael Crow, the president of Arizona State, said we are what we teach. Ron Sims, the secretary for HUD, said that a zip code should not be a life determinant. He went on to say you can never turn a community around without a strong school. And Undersecretary of Energy, Martha Cantor, said, of Education, said teachers are the gateway to a green economy. So in a sense, this summit really set the stage for us to move forward with our hope and dream, which is to create an action plan, not just a white paper for you to take home, but something that really will, in turn, motivate all of us in education to action. For our summit, I hope a lot of you are coming. There is, I think, a little tick for those of you who are coming, and we want very much to be sharing ideas during this day-and-a-half session, but really earmark those ideas that have leverage. We want to try to figure out what are those low-energy, low-cost, low-time frame actions that can really make a big difference, and see if we can't just check some of those off the proverbial list. We want to look at which ideas are already in process or emerging, and could we scale them up. And we also want to think hard about who the other partners are, what people should be in the room for this conversation and to achieve our goals. So we're trying to frame this a little differently. We don't want it to be simply speaker after speaker. We really do want to engage a lot of you in this dialogue. The themes are emerging and still basically being honed, but we hope to have the program finalized by next week to include a section chaired by Alan Berkowitz on Foundations of Ecological and Environmental Literacy, another section on Building a Green Society through Learning and Doing. And by the way, each of these themes and panels will have a very diverse group, including media people, government people, business sector, educators, and scientists. We want to have panel number 3. We'll be seeing our world inside and out. How can we harness new technologies? That one really intrigues a lot of us who are embedded in ecological literacy, because we see our kids immersed in screens for their forests and their trees, and we recognize the divide between virtual and real, and hopefully we can harness both segments, virtual and real, in how we create an action plan for ecological literacy. Number 4, fostering lifelong learning skills. We're bringing in Brian Rosborough, who founded Earthwatch and Citizen Science, to talk and lead a panel on that particular topic. And lastly, expanding funding, strengthening public policy for environmental literacy. We have obviously a big need to talk about how we can all afford and act upon these great ideas that might come up in the panels and throughout the summit. Here's a list of our stakeholders, and of course my picture of being out on a limb as a canopy ecologist. We really hope that we can hear from each of these constituents that we have invited to the summit, because they're also important. We hope to feature a gaming jam, a new way of taking an ecological concept and turning it into a simulated game. We hope to have vendors from different technology companies there to share new and emerging ideas that excite students about learning science. And we hope, of course, to look at things that are already in existence, like standards and curricula, and determine where they will go under this new mantra from the first summit, which was change, change, change. So with that, I will now turn over to a quick little example of a couple case studies from our community. I know we're running a teensy bit behind time, so we might look at these examples, Susan, and then go into questions. What do you think about that?
Yeah, I think so. And along the way, if you do have a question you'd like to ask, you can always chat it into the chat interface, and we can address it right after Kim and David do a quick little presentation. Or you can raise your hand and let us know that you do have a question. So Kim, if you want to hit *6*, and Kim's going to share one resource that she's been working on.
Okay, this is Kim Bailey. Can you hear me?
Yep, hear you great. Thanks.
Great. Okay. And I'm from Atlanta, Georgia, and we had started a website in our state about 8 years ago to help connect our classroom teachers with all the resources for environmental education that were provided by our nature centers, our zoos, our parks, our aquariums. The teachers just didn't know these things existed, and the providers of these resources didn't have a good way to reach the teachers. So this is a website, sort of a clearinghouse, or the yellow pages for environmental education. And after we had a few years of success in Georgia, we expanded it to the Southeast region through a grant. And you can see on the slide there's 8 states in the Southeast region that are now using the same website system, and then 2 additional from outside of our region. And if you want to go to the next slide, you can see what the website includes. It's a searchable directory of the organizations. In Georgia, we have about 400 of these, and teachers can go and find who's in their community. Everything is searchable by proximity to zip code or what types of resources they offer. We also have a school directory where schools can learn from each other. One example of a search you might do would be a school within 20 miles of my school that has a composting program, and then you could learn from their example. Searchable calendar of events, a lot of professional development programs for teachers, as well as more family events, festivals that families would attend to do more informal environmental education. And then some searchable resource database, and EE News, where people can go to find out about the latest announcements. This webinar, for example, was something that we had promoted through our announcements section. New teaching resources grants, as you might imagine, are very popular part of the website for environmental education contest awards, and then also jobs and internships. So that's an overview of what we're doing in the Southeast and a couple other states, and many other states have similar systems to this as well.
Great. Thanks so much, Kim. If you can, in the chat window, put the URL to this website, that would be great. I think people would appreciate seeing that. And then go ahead and do *6* to remute your line. Thanks so much, Kim. And David, we've got your slides here, and we could always show, maybe we can show the movie a little bit later on after we get some questions in. But if you want to do *6* and tell people what you're doing, because it's a little bit different.
Great. Can you hear me?
Yes, hear you great.
Oh, excellent. So my name is David McConville. I have a company called the Illuminati, and we work very closely with science centers around the country and around the world for developing immersive visualization systems. And we were just awarded a NOAA Environmental Literacy Grant for the next 3 years to create what we're calling the Worldviews Network, which is working with science centers that have digital planetariums around the country that have traditionally used them primarily for astronomy education. We are using them to really help people to communicate ecological perspectives on the cosmos, on the globe, and on bioregions. If you could go to the next slide. These are some of the partners that we have. We actually have 12 science centers around the country, but we're working very closely with NASA and NOAA's Climate Program Office, the California Academy of Sciences, the GBH, the American Museum of Natural History, and the Denver Museum of Nature and Science. They're all using this particular real-time visualization platform called UniView. That it's essentially like a real-time powers of 10 zooming engine, so we can look at data at multiple scales. And if you go to the next slide, and the proposal is specifically to look at the conditions supporting complex life in the cosmos, then zooming into a global scale where we'll be looking at planetary boundaries of climate change, ocean acidification, and biodiversity loss specifically, and talking about NOAA's climate literacy principles. And then on the bioregional level, we'll be doing custom visualizations to help people really understand their local ecosystems. And it's beyond really just kind of sharing information. We're really doing a lot of professional development to build up an Earth Systems community of practice within the museum community. And beyond really helping them to understand these issues, we're facilitating ways of addressing the nature of what communities can be doing. We've participated very actively with NOAA in their communicating climate change programs, and something that we felt was lacking was a real design process for communities to engage and to understand what is possible and how people can really get involved with increasing the integrity and health of their own ecosystems. And then finally, we'll be doing formal evaluation of much of this. And if you go to the next slide. This is just a very quick, it's difficult to see here, but it's just a quick model of the type of approach that we're taking, where we're really focusing on seeing and making the invisible visible, knowing, working with the concept of ecological principles, and then doing to really encourage people to get involved in many of these issues. And this is a transformational learning pyramid that we're looking at that really tries to connect sort of the base level of how you understand the cosmos all the way to, what are the actions that you're taking in the world. You go to the next slide. And just a really quick overview of that is on the seeing part, these are all various screenshots of some of the geospatial visualization abilities that we have for looking at all kinds of planetary systems, all kinds of data that we've been looking. You see here the different maps of ocean temperatures. What we see on the bottom right-hand side is a map of global oil consumption from around the planet. Go to the next slide. And then we're really working within the context of planetary boundaries, very related to this call, and really trying to help people to understand that climate change is one issue that's very related to many other tipping points that have been very rigorously studied, and trying to get word out about these other issues besides climate change, even though of course climate change is quite important. And if you go to the next slide. And this is just a list of some of the principles. It's a huge list, and it's some of the things Alan was talking about in terms of really focusing on various principles. But the reason that we are focusing on these is because since these systems are interactive, we're really trying to provide a foundation for the educators so that they can begin to tailor their own their narratives and their own stories so that over time they can really evolve and teach about these different principles in the ways that they feel are appropriate. And then finally, we have one more. And the doing aspect of this, we're really focused on and really helping people to understand design processes. And this is a particular design process that I found to be very useful from the Buckminster Fuller Institute, where I'm a director there. And we really try to help people to understand, how do you choose problem situations and define problems in preferred states and provide compelling examples so that they can really understand, how these problems have been addressed in other places so that they can apply the knowledge that they've gained about complex systems to design the ways in which they're addressing them within their communities.
Thanks so much, David. This is great. I'd love to open it up to questions now, if we could, just because we're running right up against our hour here. So just before we move on, I'm going to show this picture, Meg.
Oh, sure. I could just talk really quickly as a third case study because this is the new Nature Research Center in North Carolina that I'm currently directing. It's a $60 million legislative initiative to create a 4-story high Daily Planet theater with technology that links all the schools in North Carolina, as well as the potential to link schools in India or China or throughout the U.S. And it will have platforms for informal science education, including Meet the Scientist and Investigate Labs and all sorts of technologies that will be, of course, virtual, linking to real. And the neat thing is we're hiring about 49 scientists and educators so that they will be working together to produce and hopefully raise the level of ecological literacy and science or STEM initiatives here in North Carolina. So exciting times that some of these new and outside-of-the-box programs are moving ahead. I hope we can get both Kim and David up here really fast because it was great to see what you all are doing too. So that just gives a little bit of a understanding of what's going on here, and hopefully all of these different case studies move us into our summit on October 15th, and we sure are looking forward to seeing as many of you as possible.
Yeah. So anybody have questions? I didn't see any in the chat, and I didn't see any hands raised. Kim and David have shared a few more resources in the chat window itself. Little wait time there. I'm not hearing anybody ask a question though.
Maybe that's an offshoot of this new technology, Susan. People are too busy pushing buttons.
In too many side, chat room conversations.
It's very fun having all these little artistic things.
All right.
Well, I would say that maybe because the time is up, we should have a wrap. And Susan, is there any way that we can share a list of who was involved in case people want to send questions around?
Yes, certainly. What I can do is share the participant list with everyone. And if you, in particular, saw something that you wanted to learn a little bit more about or connect with somebody, you can do it that way. Certainly, I'll include our presenters as well.
That would be so great. And I did make a little misspeak there. October 14th is when our summit begins, and October 15th is when it ends. So we just would welcome all of you to bring your outside-of-the-box ideas, your thoughts about what works and what doesn't. We're just really excited and grateful for the support of NSF and other groups to move us forward in ecological literacy.
Yeah, great. And there again is the link to the summit information. If you can take the survey, if you haven't already, it's linked to you there, and I think Teresa said it'll stay up through the end of the week. All right.
Thank you, Susan, for all this wonderful technology, too.
Oh, thank you, and thank you so much, everybody. Please help me in thanking our speakers. John and Susan and Alan, thanks so much. Really appreciate your time, the time and energy that you all put into creating this webinar today. And David and Kim, our two guest presenters as well. Thanks. Yay, we're getting some applause. So we can leave the room open just a few more minutes if anybody else did want to chat on a final question. But otherwise, take care and look forward to seeing a bunch of you at the summit. Thank you.